In this video, I'm going to talk about graphing systems of inequalities. But before I talk about systems of inequalities, which is multiple inequalities at the same time, I'm going to talk about graphing independent inequalities. There are 3 steps to doing that. The first step is to get the output by itself. So you want to isolate the y. So the first step is to isolate y. Get y by itself on one side of the inequality. The second step is to graph the guideline. The guideline is just going to be whatever the inequality is. So let's say we had y is less than 3. The guideline would be y is equal to 3. I'm just going to replace the less than sign or whatever inequality sign I have with an equal sign, and that's going to be my guideline. So just replace inequality sign with an equal sign. All right, and then the last step is to shade above or below. So shade above or below the line, and that will depend on what kind of inequality you have. We're going to shade above or below the line because there's going to be infinite answers. There are infinite answers for values where y is less than 3. Y could be 2, y could be 1, y could be 0, -1, etc. All the way to negative infinity. So there are infinite answers to that, just like there are infinite answers to an inequality that has 2 variables. We're going to talk about what the inequality sign means. It's going to tell us what kind of line we're going to have. If I have greater than or less than with no equal sign underneath, that means that the line is not included. The line is not included. So in this case here, with y is less than 3, y is equal to 3 would not be included because 3 is not less than 3. So to indicate that the line is not included, I'm going to make the line dashed. So it's going to be a dashed line because it's not included. For when I do have an equal sign underneath in my inequality, that means that the line itself is included. So it's going to be a solid line. That means the line is included. All right, we can also talk about the inequality sign will tell us where to shade. So if I have greater than or greater than or equal to, that's going to tell me that I'm going to shade above the line. I'm going to shade above. If I have less than or equal to, I'm going to shade below the line, the opposite, below the line. All right, so let's do an example. If I have -3x is less than -9, in this case, and in some cases, you will not always have both variables. So in this case, I'm going to have to just isolate the x. I want to get that one variable that I do have by itself. So I'm going to first divide by -3 on both sides to get that x by itself. And then when I divide by a negative number for an inequality, the sign is going to change. It's going to flip. So instead of less than, I'm going to have greater than. On the left-hand side, I'm going to have x, and on the right-hand side, I'll have +3. So this is the inequality I get when I isolate the variable, isolate x by itself. So step 1 is done. That's step 1. Moving on to step 2. Step 2 is to graph my guideline. So first, I want to know what is the guideline. All I'm going to do to find the guideline is take this inequality sign and I'm going to change it to an equal sign. So instead of that inequality sign, I'm going to change it to an equal sign. Everything else stays the same. Oops. I have x is equal to 3. This is my guideline. That's the guideline. This is what I'm going to be graphing. Before I graph this, I want to talk about, is it going to be a dashed line or is it going to be a solid line? I look at this inequality sign right here, I see that that is greater than, which means x is equal to 3 is not included. So this line is not included, which means I'm going to make it a dashed line. It's going to be dashed. So I'm going to graph this line on my graph here. And I know that it's going to be all points where x is equal to 3. Well, here's a point where x is equal to 3. That's 3, 0, 3, 1, 3, 2. I don't need any more points than that to see that this is a vertical line, in case you forget that when you have x is equal to a number, it's going to be a vertical line. This is going to be a dashed line along x is equal to 3. And make sure you have those arrows going on and on forever. And then I want to talk about, am I going to be shading, in this case, I'm going to be shading to the right or to the left, because those are the sides that I have. Usually it'll be clear what's above or below. And most cases you will have both variables, so you will be doing above or below the shading, but when you have a vertical line, x is equal to something as your guideline, you're going to either be shading to the right or to the left. And in this case, well, I want to know what direction would I be shading. I want to shade all values, all points where x is greater than 3. So where's a point where x is greater than 3? Well, 4, 0, that's x is greater than 3 there. X is greater than 3 here and here. So I'll be shading to the right of this line. You're never going to be shading to both sides. So if points on the right-hand side make sense, make the statement true, you just need 1 point to know that that is the side you'll be shading. Okay, so there's my answer. For graphing systems of inequalities, so that's multiple inequalities, it's usually just 2 inequalities at the same time. I'm going to do the same first step. I'm going to get that y by itself. I want to isolate y. So first step is to isolate y for both inequalities. The next thing I want to do is graph the guidelines. So I'm graphing 2 guidelines on the same graph. I want to graph both guidelines on the same graph. And my last step is to shade above or below the lines. So I'm going to shade above or below, depending on what's the inequality sign for both the inequalities. And then I know that the double shaded region is where all solutions are. We call that double shaded region the feasible region. It's called the feasible region. And that is the solution to the system, the feasible region. Okay. Feasible region. All right, so let's do an example. I have this system of 2 inequalities and I want to graph it. So the first thing that I would have done, but I don't have to do, is isolate y, because y is already isolated for both of these inequalities. I don't need to do step 1. Step 1 is done. Step 2 is to graph both guidelines on the same graph. So I'm going to find the guidelines and graph them. I have the guideline for this inequality. All I'm going to do is change that less than sign to an equal sign, and everything else stays the same. So I have y is equal to negative x minus 2. I know my y-intercept in this case, my y-intercept is -2, so I'm going to plot that. I'm going to plot my y-intercept is -2. And then I know that the slope is going to be -1. So if the slope is -1, that means that my slope I can write as -1/1. That means I'm going down 1 to the right 1 from my y-intercept, which is a point I know is on that line. So I'm going down 1, right 1, down 1, right 1, down 1, right 1. Then if I want to go to the left, I'm going up to the left 1, up 1 to the left 1. Right, and then I can connect this line. But before I connect it, I need to talk about, is it going to be dashed or is it going to be shaded? And since I have a less than sign here, that means it will be, sorry, did I say shaded? I meant solid. It will be a dashed line because that line, y is equal to -x minus 2, that is not included. It's not going to be included, so it's going to be a dashed line. So I'm going to draw a dashed line here. Doesn't have to be perfect. Oops, there's my dashed line. All right, and now I'm going to shade. So I'm just going to do the shading for this before I move on to the next inequality. So I'm doing step 3 for this inequality first. I want to shade above this line, so I should be shading this direction. Wait, I'm so sorry. What was that inequality? Less than. I should be shading below. I should be shading below, not above, because it says less than. Okay. All right, and now let's do the next inequality. So I have y is less than or equal to 3x plus 6. My guideline, I'm just changing that less than or equal to an equal to sign. Everything else stays the same. This is my guideline. That is what I'm going to be graphing. So to graph this, I know 6 is my y-intercept. I'm going to graph that first. So 6 is my y-intercept. 1, 2, 3, 4, 6. Why do I do this? All right, and then next I'm going to look at the slope. I know the slope is equal to 3, so I could write that as a fraction, 3/1, which means I'm moving up 3 to the right 1. Up 3 to the right 1. I can't do that from this point and have a point on the graph, so I'm going to go to the left. So I'm going to go down 3 to the left 1, down 3 to the left 1, and I don't need any more points than that. I just need 3 points. This is going to be, because I have less than or equal to, I know it's going to be a solid line. It's going to be a solid line. That guideline is included. All right, so solid line through that. That is a terrible line. Okay, good enough. And then I'm going to, actually that's not good at all, but doesn't matter. Then I'm going to shade below that line because I have less than or equal to, so I know that it's going to be below the line. Maybe it's not obvious what below the line is, so we can always check a point, and the easiest point for us to check is 0, 0. That's on what I would say is the right side of that line. So I'm going to plug in 0, 0 and see if that satisfies this inequality. I have, if I plug in y is 0, x is 0, I'm going to have 0 is less than or equal to 6. Is that true? Yes, it is, which means 0, 0 is included, which means I'm shading this side. So I'm going to shade to the right-hand side. And it's always easiest to check. If you're not sure, it's always easiest to check with 0, 0. I recommend using that one, that point. if you need to check. All right. The answer to this system is just going to be the double shaded region. So this purple section right here, that is the answer, the double shaded region, and we call this region, again, the feasible region. And that's our solution. All points here satisfy both of these inequalities.